Well, in the last video, we have seen the threads and multi-thread execution, part 1. In that part 1, we have seen what is process, what is task, and what is thread. And next, I have explained the importance of threads. Why threads are required in the programming. Next one is synchronous. And I made it into a short like this. Simultaneous plus sequential. Simultaneous plus sequential is equal to synchronous. Simultaneous plus sequential is equal to synchronous. Today we want to run simultaneously. One thread, one thread, one thread, one thread, one thread, one thread. And execute this thread, then this thread, then this thread, this thread. This type of execution is better. But actually, when you are implementing thread, one thing happens that for each thread, the thread scheduler will allocate some amount of time, some 0.5 milliseconds resolution. For another thread also, thread scheduler may not guarantee that I'll allocate same equal amount of time for all the threads. The next time when this thread is executing, the system load may be more, but I may be allocating only 0.04 milliseconds. For another thread, it may say that I may allocate 0.07 milliseconds for this thread execution. The thread scheduler cannot guarantee that I'll allocate equal amount of time for all the threads to execute, but I'll make sure that all the threads will execute simultaneously. In once allocated time of 0.05 milliseconds, the generator thread or generate printable, which is calling for loop for 100 times and calling generate method for 100 times. In this 0.05 milliseconds of time, that for loop may iterate for 20 times or 30 times. Until that generate method executes. After that time, the control will be given to the second thread. Again from here, the print method is called for 30 to 40 times. Or maybe because of less time, maybe some 15 to 35 times, something like that. Or some 25 times. There may be one more method, again that method is also being called for 100 times. That method may be called in its 100 iterations within this allocated amount of time. Here, it may be executed for more than some 40 to 50 times in its allocated time. This thread will call its corresponding method in the for loop iteration for 40 to 50 times. And each thread within its given amount of time, it may call its corresponding method maybe for 10, 15, 25, 30, 40, 50 times. Once its time is completed, control will go to next thread. From there, go to next thread again to first thread and second, then third, and then go to first thread. This is how threads are executing simultaneously. This type of execution is correct. This type of execution is correct. This type of execution is correct if the methods here, generate method, print method, and some other method, if these methods are independent methods, these type of execution is the right execution. If methods running in these threads are individual methods, and if no method depends its execution on other method, generate method runs separately, print method runs separately, this method runs separately for 100 times. Each method is an independent method, not a dependent methods. If they are dependent, first method produces some output, the second method must correspond. Second method will produce some output, that third method must correspond. Third method produces some output, that again first method consumes. Like that, if one method produces output, second method produces output, if third method consumes, and again third method produces output, first method consumes, and if like that, if all the three methods are want to run simultaneously only they want to run in the threads, but they want to run sequentially. Sequentially means in the allocated time of thread 1, it should call its method for only one time. Because one time execution of the generate method will produce some output that the print method in the second thread want to consume. So hence, generate method should execute only one time, though it is having 20 to 30 more iterations to run. Generate method should stop its execution. Control should be given to print. Print will consume that output. Until print method execution is completed, once print method execution is completed, its output depends on the third one. It may depend or may not depend, but once print method execution, second method execution is completed, though it is having time 15 to 25 times more to complete, to complete its method calling iterations, print method should stop and should give control to the third method for execution. Third method should execute one time and again should give into first method. Then first to second, second to third, then to one, third to one, like that and so on. In these threads also, each method want to run for only one time and then it should interrupt for the second method execute, then it interrupt and then third method execute. Like that, because methods are one dependent on other. Methods are one dependent on other. The methods running in these threads also want to run sequentially but simultaneously because of thread execution. Sequentially also. Because each method want to run in each of the simultaneous execution for one time. That is what I mean, simultaneous plus sequential is equal to synchronization. We'll see how to implement that synchronous execution right now. In synchronous execution also, we are having two types of executions. That the first one is method synchronization. Second one is object synchronization. The first example is on method synchronization that we'll see first. Read the paragraph here. The two advantages of threads. Let's multiple threads or methods run simultaneously. Utilize system resources efficiently, optimally, no waste of CPU life cycles or system resources. But threads output is unpredictable. Thread executions are uncontrollable. If threads execution want to be controllable, we need to do thread synchronization. Then how to do method synchronization? This is method synchronization. In this method synchronization, if you carefully observe, forget about the thread classes and client program. Thread classes and client programs remain same. Extends thread constructor to receive number generator object from the run method, iterate while loop, for loop, call generate and print method for 100 times, create object of the number generator object, pass them into thread class constructors, create thread objects and start threads. The entire process remains same. But in the method synchronization, the difference in the implementation lies in the generate method implementation and print method implementation. The actual logic lies, the difference lies in the generate method and print method implementation. Please observe the generate method and print method implementation for some time. After that, I'll explain. So here I named class name as number generator synchronized class. Means synchronized class. Number generator synchronized class NGS. Okay. In this class, we declared two variables called one is counter and the other one is boolean flag. For what this integer counter, int counter, and one is boolean flag? Think for some time and after that I'll come to the explanation. Counter variable means the variable is resembling it acts like a counter. whose value will increment from 1 to 2, 3, 4, 5, 6, so on. Probably who will generate that counter variable value? In my guess, because there are two methods, generate and print method, it is the responsibility of the generate method to produce each time one integer value. That integer value, incremented integer value is nothing but counter. The generate method may probably produce counter value from 0 to 1, 2, 3, 4, 5, 6, 7 and go on. And that such a generate method produced value, counter value, want to be consumed by print method. Until one time if generate method produces something, immediately that value want to be consumed by print method. So once generate method produces one value, it should interrupt, then print method should execute, it should consume, then again it should interrupt, then this method will produce one more, then it should interrupt, then this method will produce, this method will consume the output like that. Like that, each method soon after its execution is completed, it should wait until second method execution is completed. Once that execution is completed and that is interrupted again, first method will execute like that. Then in order to, how does we know that whether generate method is executing or print method is executing? Which method is executing? Which method want to wait or interrupt for some time? So how do we calculate? How do we decide? How do we judge? That we want to calculate. That we want to calculate. That we want to calculate by using one variable called Boolean. Why I'm using Boolean? Because if Boolean value is true, something like generate method want to execute. If Boolean value is false, that means generate method want to stop and then print method want to continue. If flag value is false, print method want to execute, and once the flag method becomes true, the print method want to stop and then generate method want to execute. And one Boolean value makes one method execution and other method execution interrupt, and false makes one method execution execute and one method into interrupt state. Then the Boolean will determine which method to execute and which method to interrupt. Because we are having only two threads, we took simple, Boolean variable. So you may get a doubt. Suppose if I am having more than two methods, 3 methods synchronization, 4 methods synchronization, 5 methods synchronization, what to do? Do one thing. Take one integer variable, take one character variable, take one integer variable. If it is 0, execute generate. If it is 1, execute print. If it is 2, print third method. If it is 3, print fourth method. Again 1, 0, first method. If you not take one character variable, character ch is equal to A means one method, B means another method, C means another method, D means another method, like that. So by using an integer value or character value, we can control more than two methods of synchronization also. It's only just lies in the checking the condition here. Okay. Now coming to the generate method. So from where this generate method is called from? Actually, this generate method is called from generate method synchronization thread class or run method is calling generate method for 100 times. Generate method synchronization thread. Generate method, the two in synchronized way. That thread class is calling the generate method for 100 times. Similarly, print method synchronization thread class run method calls print method for 100 times. Same like the previous 3 examples. This is the 4th example on threads. Okay. So and from where they are called from? They are called from client. Simple. Number generator synchronization class object is created in the client. That object is passed into generate method synchronization thread and print method synchronization thread, and the threads are started. So client program also remains same, exactly same, except changing the class names and found any difference in the previous three examples compared with this example. But whenever the generate method synchronization thread starts and then print method synchronization thread starts, generate method synchronization starts. The moment that method is called, immediately GMST will come to thread scheduler. Its run method is called first time. Generate method synchronization thread class run method execution starts first time. The control will come here. So it is the first iteration. The first iteration generate method is called once. And into that, what is the value passed here? The value passed here is initial value 0. 0 will be passed. Next time it will be 1, 2, 3, and 4, so on up to less than 100 and 99. 0 to 99 is 100 values. And during the first thread executions, first iteration, the first time value is 0. Okay. Value is 0. Okay. That value comes to generate. The current value is 0. We wrote one debug statement called generate method called. Fine. Then try block is written here. For some reason, try block is written. We don't want to discuss about that. Try block is written. Inside try block, I'll tell you. Try block, we are checking. While flag value is true, as long as flag value is true, we are calling wait. What does it mean? And whenever the flag value becomes true, because we are calling wait, what do you mean by wait? Wait is a method which tells, wait is a method in thread API that tells whichever thread is calling generate, whichever thread is calling generate method, that thread want to wait. Wait doesn't mean waits the method. Wait instructs the method's corresponding thread to go to wait state. That is how the while loop is closed and try block is closed here, catch is closed here, this try catch block is closed here. But tell me, what is the default value of flag? Is it true or false? It's false. Flag value, default value is false. Generate method is called first method. Run method's first iteration, first thread, first iteration, first time method called, the value is 0 here in the generate method. The time the flag value is false. It's not true. Because of flag value is false, this condition won't be successful. No control enters into this while loop. This complete block will be ignored. Whatever I value comes here, that I value will be assigned to counter. And initially counter value is 0. Assigning that I value to counter variable itself is value generation. The next system.printl generate method executed. And all the system.printl statements are only just for debugging sake. Debugging sake to know how many times generate method is called from each of its iteration. Okay. And once I variable is assigned to counter, what does it mean? Generate method has produced one integer value. Directly or indirectly. By receiving from somewhere, generate method assigned that value to counter variable. That means one value is generated. Immediately flag value we made to true. Flag value is equal to true. flag value is equal to true, we change it because generate method execution is completed. It has produced one value to indicate that the flag value we made it true. Okay. After that, we are calling notify method here. What does it mean? We are calling notify method here. We are calling notify method here. This notify method is an intimation to the thread scheduler. This notify method is an intimation to the thread scheduler. If any threads are in the wait state, if first method is or first thread is running, remaining methods are in wait state only now. This notify method says in the thread scheduler, if any methods are in wait state next to this thread, they are notified to start their execution. If any method or threads are in the wait state, then the notify method notifies those methods to run. And the next thread in the thread scheduler is ready to run, notified, but control is not given yet. Why control is not given yet? Because as per the thread's execution, once allotted time of this generate method synchronization thread, this run method can call generate method for continuously for 10 times to 20 times. That much time is allocated for this generate method. Within the time, its run method can call generate method for 10 to 20 times minimum. So first time method is called, value 0 is passed into generate method, that value has been consumed. Now what happens? This time value 1 will be passed. Value 1 will be passed. This time, once again, the control will come here. Once again, the value 1 will be passed. Previously 0, now this time 1. Control will now again to generate method. Control again came to generate method. This time the value is 1. SOP, generate method called. But before coming to consuming the value 1 and executing the remaining logic, the control entered into val flag is equal to true. Is flag value is true or not? Flag value is true. Because the flag value is true, immediately the wait method called here intimates to the generate method's corresponding thread. Generate method's corresponding thread means this one, generate method synchronization thread. This wait method instructs this generate method corresponding thread to go to wait state. Once this method goes to wait state, it's not dead state, it's a wait state. Wait state you can represent something like, somehow like exclamation, something like that. Once the first thread goes to wait state, then second thread which has been notified already, that execution will start. Once the second thread execution starts, that means this print method synchronization thread starts. Its corresponding run method will call the print method for first time. Among its 100 iterations, first time the print method is called. Now the control will come to print. System.out.println just only for debugging sake. Print method is called. Once print method is called, control comes here. Before executing the remaining logic, control will enter into true. Flag value is false. What is flag value? Last time, once generate method execution is completed, the flag value become a true. Now this time the flag value is true. Because of true, control never enters into this block, this try block. Counter value is so and so. What is the previous counter value? 1, 0. Previously sent value is 0. This one is not assigned at. The previous counter variable value is 0. That will be printed. Flag is equal to false. Notify If any threads are in the wait state, if there are only 2 threads, again first thread is in the wait state. It instructs the thread scheduler, if any threads are in wait state, they want to be resumed. But the current thread should go to wait state. How? Notify. Again, control comes to one more iteration. First iteration is completed. One more iteration on print method. One more iteration of print method. Second time when print method control comes, and second time when print method is called, control comes to print method for second time. That time the flag value is false. Once flag value is false, the print method corresponding thread was instructed to go to wait state. And once if this thread goes to wait state, which thread next in the execution? Generate. What are the flag value is now? False. Value will produce flag to true. Notify. Next time, flag is because of true. Wait. This method goes to wait state. This is how each method, soon its execution is completed, it is changing its value. That value, the same method will check if the value is true or false. Based on that, the method will instruct its corresponding threads to go to wait state, resumes other waiting threads to run through a notify method. They'll execute. Again, they will go to wait state. Again, they'll notify other threads to run. That is how the context switching takes place between both the threads. And such two methods are called from generate method synchronization thread and print method synchronization thread. From here, these two threads are started. Client program execution. Client program starts both the thread executions from here. Now the threads starting from here are not the two normal methods. This is a method synchronization example. In this example, the threads will execute simultaneously, but each method executes in its iteration for only once. So it is sequential. Simultaneous plus sequential is equal to synchronous. One thing you should observe throughout this example is, previously the generate method and print method are just implemented only as void print, void generate. Or maybe probably they might have prefixed with the public access specifier. But the methods are not prefixed with the synchronized. But the methods are not prefixed with synchronized like this here. Synchronize like this. Synchronize like this. Synchronize here, synchronize here. Like this. Synchronize here. This is called as method. The two type of synchronizations, method synchronization and object synchronization. Class synchronization is also there, but we don't want to discuss class synchronization. We'll discuss only method synchronization and object synchronization. This is called as method synchronization. Both generated and print methods are declared as synchronized. Because of that reason, these two methods will participate in method synchronization. If one method is synchronized and another method is not synchronized, then such method synchronization doesn't take place. If these two methods are synchronized and if you write another method to that another thread, if that method is not synchronized, that method will run without synchronization, asynchronously. These two methods will run synchronously. So here declaring methods, and methods which are having this wait method, notify method, such methods must be declared as synchronized as well. Otherwise, these two methods will not be synchronized. One more very important point. During such method synchronization or object synchronizations, if any variable in the class is declared as volatile, some variable name, such volatile variables used in these method synchronizations are in object synchronizations, are not synchronized because of they are declared as volatile. Volatile means variables which do not want to be affected from the object or method synchronization, whose values to change. who do not want to be influenced by the method synchronization or object synchronization, whose methods value want to change even in the synchronization blocks also. Such variables are declared as volatile. I didn't say any occasions on volatile variables so far, but we can use it in threads. If you declare one volatile variable here, when this thread is running, in other threads you try to modify the variable, then there you can see the significance of volatile variable. The problem, finally, I want to conclude this topic. The problem in method synchronization is the synchronization is static. The problem in method synchronization is the synchronization is static. Why synchronization? This synchronization is static because methods are already declared as synchronized. Generate and print methods are already declared as synchronized. But they are called from normal threads. They are executed normally from the client. Client is not having any synchronization logic. The threads are not having any synchronization logic. Only methods are declared as synchronized. Only methods which are being called in the threads. Only those methods are synchronized. Because of this reason, there is one advantage and one disadvantage. Because methods are declared as synchronized, these methods need not be synchronized in the threads again. But main drawback is, suppose in future if this generate method do not want to run as a synchronized method, and print method also want to run as a normal method, they do not want to run as a synchronized method, because synchronization increases consistency, decreases performance. Synchronization increases consistency, reduces performance. Performance reduced means compared with concurrent execution, performance will be reduced. Because of increased consistency and reduced performance, tomorrow if the generate and print methods want to run as a normal methods, if the synchronization keyword do not want to be there, these methods do not want to be synchronized, you cannot come and modify method signature here. And once written methods, generate and print method, prefix with synchronized, cannot be removed in future, because once a class and methods are returned, they cannot, and compiled, they cannot be modified again and again. A lot of inconsistency takes place in the coding. So, how do, and if method generate and print method want to run synchronously, they want to run synchronously. They don't want to run synchronously, they don't want to run synchronously. But how client can control them? Because if the methods are already declared as synchronized, the client who is using these methods cannot do anything. He cannot, she cannot control synchronization on these two generate and print methods. Then what to do? Then in that case, remove methods as synchronized. In that case, remove methods are synchronized. If they want to run simultaneously, we cannot run them. Whereas while calling, okay. Then you remove synchronization to the methods. Synchronization to the methods. And then what you do is, the method from where we are calling this generate and print method, we put this calling block, we'll put this calling block, we'll put this calling block in a, we'll put this calling block in a synchronized object block. We'll put this generate and print method calling these statements in a synchronized object block. Method synchronization keyword is removed, but logic remains same. Instead of declaring method as synchronized, we'll call these methods from the synchronized block. Once these methods are called from the synchronized block, same effect will happen here. Advantages. Methods are now declared as synchronized. Clients who are calling the generate and print method, if they want to run methods in a synchronized manner, they'll call it from synchronized block. If not, they'll simply remove. Clients will remove synchronized block in the thread implementation. Okay. If I'm using some third party method, if I want, I'll synchronize it, otherwise I'll run normally. But if methods are already prior declared as synchronized, I cannot remove them. So whether threads want to synchronize or not should be controlled by the developer or client who is using the methods, but not developer who is writing the method. Logic should be written according to that, the weight and notice of methods. But synchronize keyword putting that statement should be left to the developer or client who is using the method. So that is the recommended way in thread synchronization. So in one more presentation, we'll see how to make how to do objects synchronization as well. Until then, we'll end up this session. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.